It's going to be 50,000, 100,000 satellites in space.
You'll be shocked about the actual cost per gigabyte of these companies.
You try to do it yourself, it means you're never going to be profitable.
This conundrum of being in love with the technology that they like instead of being in love with the challenge that they solve. Rusty, thanks for joining.
Thanks for having me, Ray.
Thanks for giving talks to our inspired
It was
space
a great
cadets.
group. You've got a great group of people at Space Challenges. That place is rocking with all kinds of great technology. They're working on great little projects.
Yeah, we have this year 45 students from 14 nations. And I'm hoping that few of them will decide to join our crazy ideas and concepts.
They were very excited about what we're doing. I think we're going to have a good shot of recruiting some of those great people. It's going to be awesome.
You have a great CV, and we just started working together a few months ago, and I was deeply impressed by your CV. I was also deeply impressed that usually I'm a tall guy, but I look not as tall next to you.
Yes, I am. You're tall. I am ludicrously tall.
Even
different.
even on the photos, I need to probably put a few books and step on them like a proper Eastern European dictator.
Exactly,
just a few important.
Or if I can find a way to give someone 4 inches of my height, I will do it, because it's all paint on airplanes now. Being 6'8" is not the best thing in the world.
Yeah, this is actually really interesting that you are also a pilot. Can you tell a little bit about yourself? Your story is quite fascinating, and you have gone through the military, and then you are having a significant work at SpaceX and other entities. So
I've had a wonderful run. I've been loving everything I'm doing, loving what I'm doing now. Sure. So the quick version of me is grew up in the Midwest of the United States, but I come from an engineering family. So I got to go to school, become an engineer, had a great opportunity as a Purdue co-op to work for NASA space shuttles and learn how all the great work that had come before in the world by what NASA developed in the space shuttle, and learn how to do space in the grand scheme of what's going on out there. But early in my career, I moved to the commercial side, and in the early 1990s, I got a chance to work at Motorola on the Iridium first constellation, the first real commercial constellation where small-sat and the small-sat revolution started to come alive. And they thought we were crazy because we were going to put up 100 satellites. Yes, they thought this was a crazy number, right? And the fact that we were going to launch multiple satellites on one rocket was going to be crazy. But we actually showed that this would work. The architecture was in play, and Iridium is a strong, vibrant company today, doing a great job of moving low-rate data to anywhere on the planet that you need to do, because they moved in this direction with the commercial small sats. And so I did that, and then got the opportunity to go to the next level up, which was broadband communication, and from space, and went to a place called Teledesic, which was the early Internet in the Sky 0.1. And I loved that. It was a great opportunity. We were a little early. This is a thing that happens with innovative companies. A lot of times you are for a few years too early from where the technology can actually do what the market wants to do. So we decided not to pursue it. We gave the spectrum back to the FCC, but we learned how to build an architecture for 1,000 satellites, and that also small sats proliferated, non-geostationary satellites, and that architecture is still alive. That's what Starlink and Kuiper and all the companies that are out there, we've matured. Technology has matured. As things have miniaturized, and we've gotten to be, the technology sets that can do all these great things have come alive with phased array antennas. They're now getting to not just 1,000 satellites, but there are 7,000 or 8,000 satellites in orbit today, right? And you look back at the start of my career, and that would have blown everybody's mind that we could actually get to this point. And I say, as I've gone through these phases, and I got to go with SpaceX and helped get the Dragon up to the space station, and helped do the first landing legs that landed the first stages on the ground, and got reuse of the stages and reuse of the capsules going. We're starting to see all these technology come alive, so that not only are we able to put a lot of satellites in space and have the technology to do all this great work, but the cost point is coming so that almost anybody can start to think about how they can do missions from space at a price point and a schedule point that is totally feasible for almost anybody. So I'm seeing the phase where we're at with EnduroSat, and we're able to bring our technology and the investment we've made in the small sats and the under a year delivery and $2 million buses, and we're able to bring this out in a way that I see the future. There's going to be not 7 or 8,000 satellites. I think there's going to be 20, 50, 100,000 satellites in space in the not too distant future. So I've had a wonderful career. Got a chance to work at Amazon Kuiper and help get their government side set up so how they can bring all that great proliferated small sat communication to the world and to the governments of the world. And now I'm here, and I think with the just like what we did at SpaceX, where we brought the infrastructure approach to launch so that you can actually get way more mass into space for a certain amount of money. We're doing that at the bus level here, at the satellite level, so that you can actually start to think about whatever your mission is, you can get to space and get down to a price point like, of $1 per gigabit of data on to anything we want from space, which is going to be a revolutionary point for all the types of ISR, all the types of communication, all the type of government missions that are out there. They're all moving away from the big, huge satellites that started the world. Back when I started my career, the space shuttle would take up these 10,000 pound satellites. Now we're seeing these 50, 100, 200 kilogram satellites that can do amazing missions. Just like our iPhones have shrunk and cell phones have shrunk, satellites have shrunk, and we can start to think about, like the iPhone, you can put all these applications on the iPhone and do amazing things because that infrastructure is now miniaturized and low cost. We can do that with the EnduroSat technology we're coming alive. So I'm very excited about everything.
Yeah, what I always tend to believe is, and to see in the space industry, is what I think is heavily not understood even by a lot of colleagues in the space industry, is that about 75 to 80% of the space companies are actually data companies. They generate some kind of valuable data, and then they sell it to terrestrial businesses on the ground via services or applications. And in the early ages, of course, there were no whatsoever alternatives that were cheap enough and fast enough to build satellites for those newcomers, and they decided, well, let's build it ourselves because there is no other solution for us. And this is how they started building the first significant constellations that we know of today. And again, I have huge respect to those founders and their teams and their resilience, and the fact that they have so many satellites successfully flying is an achievement by itself. But as a business, this decision has proven time and time again to be exceptionally damaging their business case. Because if you are a data company, you should verticalize in data, and you should take all the effort in the world to focus as much as possible the efforts of your team only where it matters, which is the data, the analytics, the applications, while they are trying to build also their infrastructure, believing this is the cheapest and better way to do it. I always give this example. It's like you being an Uber and deciding tomorrow morning for 60-70% of your time and money and capital basically to build cars and to build roads.
No,
but somehow this is still happening in the space industry, and the statistics show that there is hardly any constellation that is even little profitable. They're all losing insane amount of money, and without one or two exceptions. And the question is, what needs to change for this to start functioning in a normal way scenario? Because my bet as a founder of EnduroSat has always been, no, there is a huge need of strong infrastructure builders that take care of infrastructure, and those are verticalizing and should verticalize in satellite technology and operations of the satellite. And then they're the overwhelmingly interesting space data companies whose business is data, and they should verticalize into the data, into analytics, embedding AI in their systems, and making sure that their satellite-driven analytics can go into the hands of small, medium-sized enterprise around the planet, defense agencies, governments, at a cost that everyone would love to consume this data, and tangibly impact positively their businesses and their cases.
No, you nail it on the head. And I see that's what the whole industry is pivoting to. And we're on the forefront of the infrastructure doing that right. The two analogies that I like to use to make that point that you're hitting on the head exactly right is, imagine if every app developer for the iPhone developed their own iPhone. and then they tried to sell this to everybody, right? It makes no sense, right? You should have all these great applications that can go on a common iPhone, and there's more than one type of iPhone. There's an iPhone, and there's the Google phone, and there's the other phones. You don't have just one phone, but you don't have a single phone that you develop for every application. This doesn't make any sense, right? And that's what has happened in the past in the space industry. Everybody thinks about their mission, their data, and the mission layer of how you're going to do what you're supposed to do for your customers, whether it's commercial or whether it's government. You have that mission layer with the data. And that's where you want to focus if you're doing the job. The lower levels of this, the infrastructure, whatever the payload elements is, that's very related to the mission. Maybe that's a little that should be customized. But the bus, the spacecraft that provides the data, avionics, the solar arrays, the attitude control, the Delta V capability, all of this is structure and thermal is pretty common. And there should be no reason for everybody to develop their own version of that every time. So I really think that as the world goes forward, there are companies that I believe are successful. I think at this SpaceX, I believe, is making money on Starlink, and I'm certain that how they manage things, they're going to make money and going forward. Iridium had problems early on, went through bankruptcy, but has now been successful, and now is already thinking about its third generation that might come along because they launched their second generation satellites a few years ago. But you're right, the majority have a trouble because they're trying to develop the data and the services and how they work their users and all the software that you need to make that work at the mission layer. And while they're also trying to develop the payloads and the buses, and even some companies go all the way to launch vehicle, right? SpaceX has been successful because they can do that, but it was a huge amount of capital investment to get that level, a huge amount of time and effort to have
and also
all
even
those
with them,
levels.
by the way, it was step by step. It was not like day one, let's do everything almighty.
Yeah. They started at the bottom.
Yeah.
They started at launch, and they moved up to spacecraft, and they moved up to some payloads, and now they're doing the mission layer, and they're doing the data with Starlink, and they're doing some work with the government, I believe, at the mission layer. But yeah, they moved from the foundation and moved up. Versus the efficient way is once you have the infrastructure of launch, everybody shouldn't develop their own launch vehicle. That doesn't make any sense at all. Everybody shouldn't develop their own bus. They should be able to spend their money and their capital investment and their R&D investment at that mission layer, maybe at the payload element, and then use the modular approach for the buses, and then also use the common launch vehicles to get themselves into space. So launch vehicles and the buses, we really want to have that as a easy to integrate modular approach that anybody can open up the configurator like we have and figure out how to put their mission and their payload into the infrastructure, and then we will from there show how they can quickly and easily integrate to the bus, onto the launch vehicle, into space, and then do their mission with a minimal amount of investment at the infrastructure level, because we've already done that and other companies have already done that, and so it becomes very simple.
And this is what we are betting on the future, right? So it's the idea of there will be a moment of time very soon, I believe, where there will be the one or two TSMC-like players in the satellite industry, simplifying the way that you build satellites and put any type of sensor to orbit. Hopefully, we win this game.
Well, hopefully, we're in there. Yes, absolutely.
Then there will be companies like NVIDIA, so inventing new type of technology and payloads and materially creating the technology stack behind the innovations, and then most of the companies will be the open AIs and
the App Store, all the apps.
So the idea is that I'm really surprised that most of the satellite industry is governed and managed by incredibly intelligent people, actually vastly more intelligent than myself for sure, and it's a real fact, right? But most of them seem always to end up into this conundrum of being in love with the technology that they like instead of being in love with the challenge that they solve, and this kind of creates this dissonance in the business that they run. I mean, if it's very painful when you see a business that has spent hundreds of millions of dollars of capital and it's nowhere near profitability, and not because you don't have functioning satellites, not because you don't downlink enough data, not because data might not be sensible, totally the opposite, but it's the sum of the parts at the cost that you're doing it that completely destroys the whole concept.
Amortizing all that cost across all those layers, when you try to do it yourself, it means you're never going to be profitable.
And on the other side, in our industry, on the infrastructure level, I see other kind of delusion, I would say, to be contrarian, where you start building factories and manufacturing, and everyone talks about mass manufacturing. I don't think that most of the world in our industry understands what mass manufacturing means. There is serious production, which means like few hundred, few thousand units, and that's okay. There is the mass manufacturing of using the technologies to build million parts. If you start building a factory for million satellites, but there is actually the need for 100 or 1,000 or even 10,000, you're already kind of dead financially, because you are setting up your business and the way that you build infrastructure for failure on a financial level. Just imagine what it means for a smaller or medium-sized enterprise, even with a few hundred people, putting few hundred million in assembly lines and facilities and optimization. How this would help you get the cost per gigabyte to the acceptable level? Because today, the other thing that is very interesting is how people calculate the cost of their service. And this is, in my opinion, a bit of dissonance, because if you take the total expenditure done for you getting your infrastructure in orbit and operating it nominally for the lifetime of the satellites, and you divide it by the amount of data, whether it's a high resolution imagery or a radar data or whatever the case might be, this gives you the real cost per gigabyte of acquisition of data. And then you'll be shocked about the actual cost per gigabyte of these companies. And of course, they don't sell this actual cost to the customer, because they will have no customers in this case. So they're betting on the future. Well, I'm going to sell it expensive enough, but I'm going to sell it at a cost where I'm losing basically money from every sale that I do. And this has been proven also, in my opinion, not to work very well in the last 5-10 years. And I believe if you're an infrastructure business, you should be very sensible about the supply chain, about how you design the system of a satellite, the bus, to be as standardized as possible, and how you simplify the game basically, how you shorten the time for your customers to get to orbit, and how do you produce or manufacture them in the most efficient way possible. It's not to brag, well, my satellite is bigger than yours, or my number of satellites is bigger than your number of satellites, because this kind of measuring contest that you inevitably lose sight of why you exist in first place. And I tend to believe we exist as a business to solve one concrete challenge. How do you democratize access to space data, which means get to orbit any type of sensor and deliver as much as humanly possible data from this sensor to the ground, hopefully near lifetime, or on very soon also lifetime if few of our bets work out well. So what do you think about that? Like, this is scaring you from the perspective of the largest market, which is US, and our hope that our MIT engineering team in US would also play a vital role in that, or if you get excited?
I'm very excited.
I'm putting you on the spot. I'm putting you on the spot.
No, you're spinning me in the right direction. I get it. What's happening in the U.S. is really, there's a huge renaissance underway. In the last 10 years, as the miniaturization has occurred, and Starlink and Kuiper and other systems have shown that you can do these small satellites and potentially make the profit that you're talking about if you get it done right, and they bring mass production approaches. They've started to realize that the old model of when you launched to space in 30 years ago, the dollars per kilogram to launch was so high that you had to design everything to the minimal amount of mass. And that required optimization at every piece. You had to think about how your payload and every piece of your bus was super optimized. So you'd go through and you would have the butterfly effect, adjust one thing and 4 other things would adjust, and you had to find a way to get it super optimized. But as the price of launch has come down, that opens up the door so you don't have to have that last 2 or 3% of super optimization. And if you don't take away that optimization and just have a good modular approach that is, mass producible for the buses, and then the payloads also can be mass producible, and figure out a way to simple interface to put them together, whether it's EO or IR or SAR, the moving target indicators that the government's going to be interested in, all the communication types that are out there. All this is available now in a way that you're right, you can't build it like you build a chip manufacturing plant where you're building 1 million a day. And you can't really do it the way a car factory is, where you're doing 1,000 a day. But when we were at SpaceX, we actually did hire, and my boss, when I was there, was from BMW. They did hire executives from the car industry to bring as much of that technology as they could to the Falcon and some as we could to the Dragon, and of course it all went into the Starlink and the Starlink terminals, which are now being sold at the million level, right? So we're starting to see space technology where they do bring the 1,000 a day, 2,000 a day type technology into what we're doing, and it's working. So I'm starting to see, I'm not scared. I'm actually excited because I think as we pivot to how to bring these miniaturized and mass producible approaches, and we do just what you and I are talking about, give all of the people out there who have a great sensor, a great communication element, whatever data they want to do, the ability to focus their R&D and their capital on that invention and that differentiated product and that awesome innovation, and bring that to, and not have to spend the money building their own rocket or their own spacecraft level. They work on the mission level, at the data level. And I think what's going to happen is we're going to start to see the Kuipers now. I think they're just passing 100 satellites. They're going to start ramping up. There's a couple other constellations that are not too far behind on the commercial side. We're seeing a real wealth, I think, opening up for, I call them the enterprise and the sovereign type of constellations that are 50 or 100 or 200 satellites that do a special job. Like maybe a country wants to have its resilient communication capability. They only need 100 or 200 satellites to do that. Maybe they want to have a special ISR, 50. Maybe there's a weather type of service where you can have 20 or 50, 30 satellites that do sounding and give the databases of the world much better data for the weather information and help everybody on the planet predict where they're going to go there. The companies like John Deere, that's the enterprise side, and I'm just making up companies here, but companies that take data from the fields of where we're doing all of our planting and harvesting and fertilizing. They want to use data to make that super efficient. So there's the companies like John Deere. I know they're using Starlink already. That's public knowledge. But they might want to think about how they can actually bring awesome technology and bring their own satellites to bear. So I'm very excited as I see not only the government start to realize how we can protect space with proliferated small sats that are mass producible and use that supply chain, but the various types of constellations, from the mega constellations, thousands of satellites, to the kilo constellation. I don't know what the right word is, but they all have hundreds of satellites that are actually going to be ownable by individual companies, right? And individual companies can have their own satellite. Individual countries can have their own sets of satellites. And this is going to open up the door for all of these new applications to get the price point for the data from space where we want to go. And they're all going to be able to do their mission sets. And that's why I really think there's going to be, it's not 10,000, it's going to be 50,000, 100,000 satellites in space, not too far. And I think we're going to improve our space situational awareness, or how we track space radar, so that we can open up the orbits that we're currently using at 300 or 400 or 500 kilometers. They'll have hundreds, tens of thousands of satellites there. And I think there's going to be VLEO opening up in the not too distant future, where you're going to be down lower, where you need even less power, because now you have the R squared and R to the fourth relationship. So you're closer to the ground, so you can see things better if you're sensing, and you can communicate easier with less power. Those orbits are going to open up, and I also think some of the things that are happening very interestingly up at GEO, and even as we start thinking about cislunar and landing people on the moon, we'll have not too distant future a constellation of small satellites around the moon doing some interesting things, whether it's for GPS-like technology or communicating with things that are out there. So all of these are going to come alive, and I think what we're doing at EnduroSat to give them the ability to not have to invest at the infrastructure level and focus on what their mission is going to really be a key enabler for all of these things. So I'm very excited about it, not scared at all.
What scares you?
What?
In the coming few years, what scares you most in terms of technology, in terms of the space industry, where we're heading?
Okay. So as you start to think about things that are scary out there, you do see the fact that as we move into all these great space technology, space is still hard at the end of the day. I call it, sometimes I summarize it, I call it Space 101. Space 101 is essentially a very extensive checklist that you have to do to get things right to make sure that your system is going to work in space. So I think one of the setbacks that might happen to this as this expansion goes underway, there are big companies that have a lot of financial reserves, like Amazon, bringing Kuiper to bear, right? And it's a struggle as you move from a company that's never had their own space infrastructure capability and space mission capability to one that does. Because in the past, there's been all these great engineers who focus on making that optimization and great product happen. But there's really not that many of them. For every aerospace engineer, there's 10 civil engineers out there developing all the great bridges and houses and buildings that we have. So I think the scary part there is that as we expand into this next new world where we get 5 times or 10 times more things in space, the fact that we'll try to push a little too hard or too fast, and there might be a lot of failures in space. And as we get to some area, let's say, for example, we do get to 20 or 30,000 satellites, and we haven't quite put the space situational awareness radar systems in space, and we do start having collisions and debris becomes a problem, right? So I'm not a big believer that the Kessler syndrome is ever going to cause a horrible cascade of effects. Space is just too big. There's 1 million new particles coming in every day from deep space that are already there. So I don't believe there's ever going to be a horrible day, but there could be a bad day where people have put a lot of money in, and then because the space checklist that I'm talking about isn't quite followed because the talent is diluted, is potentially could cause some negative effects on the market when there's some failures. So one of the reasons I really think EnduroSat is going to help there is because if you have the launch is hard and the bus and satellite level is hard and the mission level is hard, and you try to focus these new companies at all of these areas, that requires a lot of talent. But if you focus all the new talent on the mission area, and we have the set of companies that are doing the good buses and the set of companies that are doing the good launch vehicles, you can get essentially 3 or 4 times as much effects out of the talent pool that you have as you expand the talent pool. So I think I'm still optimistic. I say it's a risk, but I don't think it's going to be a catastrophic risk. It's just a matter of something you have to track.
And to conclude, how do you imagine the world in the next 5 years from your lenses and perspective?
Yeah. So
the world, I mean the satellite, the space world in general. Like what do you expect to happen, and what do you expect not to happen?
Yes. I think. Well, first of all, I think watch the filings for what the big mega constellations are doing, and they're going to continue to expand. SpaceX is going to get first of all, I'll predict right now, Starship is going to work. I was at SpaceX, and I know how hard things are, and we had some failures, a couple failures when I was there, but they will fix it and get it working. And I know the people down at Starbase, many of them are friends of mine, they are working day and night. It's going to happen. When that occurs, the Starlink 2.0s are going to start flying. Direct to cell is going to open up. And there are going to be a whole new set of constellations come alive with what Starlink's going to do. So they'll continue to expand. They're at 7,000 or 8,000 today. In 5 years, that might be double, and they might have 15,000 in their next year. They're going to expand to new frequency bands. V and W band is coming alive. Optical intersatellite links are now becoming more and more common. Kuiper is coming to come alive. They're just now getting their cadence going. So 5 years from now, they could have they'll definitely have their 3,000 or 4,000 satellites flying, and they'll be thinking about the expansion to the double to 6 or 8. So you start to think about 15,000 SpaceX, 5,000 Starlinks. MDA is building a couple constellations, including Telsat, and those are going to come alive. So you start to see the big ones really explode. Not explode. I said wrong word. Wrong bad word to use, but expand. Yes, sorry. and I think then what's going to follow in right behind that is there's going to be all these enterprise and sovereign constellations that are going to come alive. I think right now, Iridium and Orbcomm and Globalstar, and there's all these 100 size constellations that are out there, and there's a handful of them. In 5 years, there's going to be 25 or 30 of these type of things, that either deployed or in launch phase, right? And I think on the way to 100 or 200 in the next 10 years, right? So there'll be the big mega constellations, and they'll continue to expand. There's room. When we were doing the analysis, I shouldn't say what company, but there's room for potentially $100 billion per year of revenue spread between the mega constellations. So if Starlink is going to be making 5 or 10 or 15 billion dollars a year, and Kuiper is going to be making 10 or 15 billion, there's still room for 2 or 3 or 4 more of those type of big things. And then that's just the big shell. And then there's these mini shells I'm talking about, that there's another tens of billions of dollars. So I just on the commercial communication satellite, I see a true expansion as the vision I was talking about. Teledesic back in the day had the concept, but the technology wasn't right. Now the first folks who have really got the small sat technology right, from the big mega constellations to the infrastructure level that we're doing here at EnduroSat, that's been invented. And now it's just like when the Wright brothers got the airplane and showed, we can actually fly. And then 5 or 10 years later, there's all these different ideas of how to do it. And you look at the beginning of World War I in 1914 to the end of World War I in 1918. This was only 15 years after this, but from 14 to 18, they went from having 4 or 5 kind of key small flights, airplanes that look like kites, to the real Sopwith Camels and all the amazing aircraft that came out at the end of World War II. That explosion is going to happen from the commercial point, and I think that's happening right now. And then speaking of military, the Golden Dome and the Missile Defense Agency in the United States with their SHIELD program, and what the intelligence communities are starting to think about how they can use proliferated small sats, are also going to come alive. And these are going to require, if you look at, if you're going to track all the, if an enemy tries to launch a lot of missiles at us, and we want to track them all from a proliferated system of satellites, well, the Space Development Agency is already showing that they can launch 100, 200 satellites a year and get these going. I think that's going to double, triple into 1,000 satellites a year for the defense and U.S. government, and NATO and its partners. I think NATO is going to play a big part of this, because there's going to be all kinds of opportunity to bring innovation from Europe into the Golden Dome type of environment. So I'm very excited about what the government's going to be doing in terms of this. So you add all that up, and you really see what when we were crazy people in the 1990s. We're thinking about 100 satellites. We're on our way to 20 or 30,000 satellites without really trying hard right now, and it's going to keep going from there. So it's going to be very exciting.
And last but not least, hopefully, if you young people in the space cadets are watching our podcasts from time to time, and what would be your message for someone younger that is starting his or her career into the space sector?
Oh my gosh, yes, yes.
What would they think? Should they know?
Be ready. Find the small, innovative companies. And I had a great professor, I'll go say his name, Professor Andrasani at Purdue. He gave us the mentorship and direction and said, always in your career, find the most innovative company and take the most innovative job in that company, and always be doing the most innovative. You will have a great career if this is the case. And if I have one thing that I've done in my career, it's I've always demanded when I interview, what are you doing that's innovative, and convince me that you're the most innovative out there, just as you did when you were bringing me on board. And you do that. If the young person is out there and they're listening to me, find the awesome, innovative companies, and the ones that want to put you in a position where you're going to be working on the most innovative thing that you can be working on in a given day. And that's kind of strategically how to just have a great career of being. If you're an engineering nerd like me, you're just going to have a blast, having all this. But the second part is, if you're young, always be in a job where you're having a little bit of fun every day, and always be in a job where you're learning something every day. If those are the two things that, independent of whatever type of thing you're doing, you will have a great career if you go.
Dusty, thank you very much for joining the team of EnduroSat. Thank you for giving the talks and the inspiration to our students' Space Challenges program. And let's keep rocking and see where we get it.
There's a lot of great stuff ahead of us, right, Joe? Looking forward to it. Thanks, man.